So good day everyone. So today I will tackle about what is curvature. So first, what is curvature? In mathematics, curvature is any of several strongly related concepts in geometry. Intuitively, the curvature is the amount by which a curve deviates from being a straight line or a surface deviates from being a plane. So the curvature can measure how fast a curve is changing direction at a given point. So we have the rate of change of directions of a curve with respect to a distance along the curve, wherein the key is the curvature, and note that the curvature of the line is equal to 0. So there are several formulas for determining the curvature for a curve. So we have S is equal to the square root of 1 plus open and close parentheses of dy over dx to the power of 2 dx, and wherein the second is ds over dx is equal to the square root of 1 plus uh, open and close parentheses of dy over dx to the power of 2, or ds over dx is equal to square root of 1 plus the open and close parenthesis of dx over dy to the power of 2. So when a curve is a given in parametric equation, so we have the formula of ds over du is equal to the square root of open and close parenthesis of dx over du to the power of 2 plus open and close parenthesis of dy over du to the power of 2, and another one is ds over du is equal to the square root of open and close parenthesis of dx over du to the power of 2 plus open and close parenthesis of dy over du to the power of 2. So for radius formula, we have r is equal to 1 over k, or 1 plus, or the open and close parenthesis of 1 plus the quantity of dy over dx to the power 2 and to the power of 3 over 2 over d to the power of 2 y over dx squared. So what is the radius of the curvature formula? So the distance from the vertex to the center of the curvature is known as the radius of curvature, so wherein the r is represented to the radius. So we have what is the curvature of a curve. So we have a smaller curvature and the larger curvature, so wherein the key is equal to d theta over ds. So when the curvature of a curve indicates how much theta changes as a function of s. So let's proceed to the example number 1. So for example number 1, we can use the parametric equation. So find ds over dx at p open and close parenthesis of x and y on the parabola of y to the power y is equal to 3x squared. So we have the formula of ds over dx is equal to 1 is equal to square root of 1 plus open and close parenthesis of dy over dx to the power of 2. So we have, you can put the value, so we have square root of 1 plus open and close parenthesis of 6x to the power of 2 is equal to ds over dx is equal to square root of 1 plus 36 x squared. So because 6 times 6 is equal to 36, so we have ds over dx is equal to square root of 1 plus 36 x squared. So for example number 2, so you may find ds over dx and ds over dy at p, x, and y on the left. So x squared plus 4y squared is equal to 8. Since 2x plus 8y, dy over dx is equal to 0, and dy over dx is equal to negative x over 1y, and dx over dy is equal to negative 4 over x. So let's proceed. So we have dx over, so we have ds over dx is equal to square root of 1 plus quantity of negative x over 4y square is equal to 1 is equal to square root of 1 plus x square over 16y squared, because 4 to the power of 2, so 4 times 4 is equal to 16, and negative x, so you can square the negative x is equal to x squared. So you have the square root of 1 plus x squared over 16y squared. So it is equal to square root of x squared plus 16y squared over 16y squared. So we have is equal to 32 minus 3x squared over 32 minus 4x squared. So then ds over dy is equal to square root of 1 plus, so you can put the value of ds over dy. So we have 4y squared over x to the power of 2 is equal to 1 plus 16y squared over x squared is equal to x squared plus 16y squared over x squared, and equal to square root of 2 plus 3y squared over 2 plus y squared. So for example number 3, so find the radius of curvature of 3x squared plus 2x minus 5 is equal to 1, wherein the y is equal to 3x squared plus 2x minus 5, and dy over dx is equal to 6x plus 2, and d to the power of 2y, and over dx squared is equal to 6. So you can use the formula of radius. So we have r is equal to the quantity of 1 plus open and close parenthesis of dy over dx to the power of 2, and 3 over 2 over absolute value of d to the power of 2 and y over dx. So we have first r is equal to 1 plus quantity of 6x plus 2 to the power of 2, and 3 over 2 over the absolute value of 6. So we have 1 open and close parenthesis of 1 plus 36x squared plus 4 plus 24x to the power of 3 over 2 over 6. So then we have 36x squared plus 4 plus 24x to the power of 3 over 2 over 6. So it is equal to 1 plus 36x squared plus 5 plus 24x, and to the power of 3 over 2 over 6. So you can put x is equal to 1. So we have r is equal to 36 x squared plus 4 plus 24x 3 to the power of 3 over 2 over 6. So we have, so you can put x to 1. So we have 65 to the power of 3 over 2 over 6. So the radius is equal to 87.34. So for example number 4, find the radius of the curvature of the curve wherein 3y is equal to x cubed at 1 and 5. So first, dy over dx is equal to x squared, and d to the power of 2 y over dx squared is equal to 2x. So we have r is equal to the quantity of 1 plus open and close parenthesis of dy over dx 2 and to the power of 3 over 2 over d to the power of 2 and y over dx squared. It is equal to 1, the quantity of 1 plus x squared over 2 over 3 over 2 over 2x is equal to open and close parenthesis of 1 plus 1 over 2 over 3 over 2 over 2 times 1 is equal to the square root of 2. So that's all, and thank you.